Hydrogen is honestly an excellent fuel choice because of its high energy density. When it's combusted, hydrogen releases a significant amount of energy, which is actually comparable to what you get from conventional gasoline engines. But unlike gasoline, hydrogen combustion produces only water vapor as a byproduct, making it both environmentally friendly and safe. Even though the concept looks really promising, there are still areas that could be improved to make these engines more practical. For example, there's a need to enhance systems for splitting water efficiently, devise safe methods for hydrogen storage, and create engines that can effectively utilize hydrogen. The goal here is to eliminate the need for complex electric or hydrogen systems. This kind of simplicity benefits electric car users, who often struggle to find charging stations, and it makes refueling a whole lot easier compared to hydrogen. Experts are curious and ask questions like, can hydrogen-powered performance match that of traditional gasoline engines? Will the driving experience be enjoyable? Hydrogen-powered engines can actually match the performance of their gasoline counterparts thanks to hydrogen's unique nature as a fuel. When hydrogen burns, it does so much faster than gasoline, resulting in rapid combustion that really enhances engine responsiveness, which is critical for driving performance. Achieving such minimal environmental impact is possible due to the unique combustion process of hydrogen engines. When hydrogen fuel is used in engines, it reacts with oxygen from the air to generate energy, with water vapor as the sole byproduct. This clean process contrasts sharply with the combustion of fossil fuels, where carbon in the fuel combines with oxygen to produce carbon dioxide. Eliminating carbon dioxide emissions from the tailpipe represents a significant step toward mitigating the environmental impacts of the automotive industry. Hybrid electric vehicles, which combine a gasoline engine with an electric motor, and plug-in hybrid electric vehicles, which can be charged by plugging in to charge their batteries, offer improved fuel efficiency and lower emissions compared to conventional gasoline vehicles. However, they still rely on gasoline and therefore produce carbon dioxide emissions during use, albeit at reduced levels compared to traditional vehicles. In contrast, hydrogen engines offer the promise of true zero-emission driving, provided that the hydrogen fuel is sourced sustainably. Another important consideration is the life cycle emissions of these vehicles. Hybrid electric vehicles and plug-in hybrid electric vehicles require batteries that use rare earth elements and involve energy-intensive manufacturing processes, presenting environmental challenges. Hydrogen fuel production mainly relies on renewable sources like wind or solar power, which can result in a more environmentally friendly life cycle compared to battery manufacturing. The efficiency of a hydrogen combustion engine is similar to that of a traditional combustion engine and can even be slightly higher in some scenarios. This is particularly significant in heavy-duty applications, where the power output of hydrogen engines can match that of hydrogen fuel cells. Fuel cells exhibit a high power peak at low loads but tend to decrease in power at high loads, unlike hydrogen combustion engines, which maintain a high peak load. This makes hydrogen combustion engines more suitable for applications requiring high performance. Technologies like Toyota's hydrogen engine are especially valuable now as the world grapples with the challenges of climate change and dwindling resources. They offer new hope for cleaner and greener transportation without sacrificing performance or practicality. Toyota is also setting a new standard with its approach to carbon neutrality, aiming to eliminate carbon footprints entirely. Toyota's holistic vision for the future doesn't stop at hydrogen combustion engines. The company is actively exploring multiple pathways to carbon neutrality, what it calls a multipathway approach. This strategy acknowledges that honestly, no single technology can solve the climate crisis across every market segment and geography. That's why Toyota is developing a portfolio of options: battery electric vehicles, plug-in hybrids, hybrid electric vehicles, and hydrogen-powered technologies, both fuel cells and combustion engines. One of the standout features of Toyota's new engine development is its potential adaptability. The same engine platform could be modified to use different types of fuel depending on market needs: gasoline, synthetic fuels, or hydrogen, making the technology more future-proof and, versatile. For example, in regions with limited charging infrastructure or where electric vehicles aren't practical due to climate or geography, hydrogen combustion engines could offer a sustainable alternative without sacrificing familiarity or ease of use. Toyota's engineers have also been working on downsizing engines without compromising performance. This includes improving thermal efficiency, how much of the fuel's energy is converted into usable power. Through advanced materials, precision engineering, and software integration, Toyota aims to achieve thermal efficiency rates of over 40%. which is a significant jump from the average internal combustion engine's efficiency. When combined with hybrid systems, the efficiency can rise even further. Another reason Toyota remains cautious about a full EV transition is due to concerns about battery material sourcing. Lithium, cobalt, and nickel, key components in EV batteries, are limited resources with high environmental and ethical concerns associated with their mining. Toyota's view is that diversifying energy and propulsion technologies, including hydrogen, could reduce the global dependency on these scarce materials. In terms of infrastructure, Toyota is partnering with other companies and governments to expand hydrogen refueling stations. This step is vital to make hydrogen-powered vehicles a practical option. Japan, South Korea, and parts of Europe are already laying the groundwork for such infrastructure, and Toyota sees its engine rollout aligning with these developments. As for market reception, early prototypes of hydrogen combustion vehicles like the Toyota GR Yaris H2 have already debuted at motorsport events to demonstrate real-world capabilities. These vehicles have shown impressive torque power delivery and zero CO2 emissions, all while offering the visceral driving feel that car enthusiasts love. By engaging the performance car community, Toyota is slowly building public awareness and acceptance of hydrogen combustion tech. The big picture? Toyota isn't rejecting electric vehicles, it's simply not betting everything on them. With its new engine, Toyota is challenging the auto industry's current trajectory and offering a compelling middle path, one that combines innovation, environmental responsibility, and practicality. If Toyota's new engine proves successful, it could redefine what clean energy vehicles mean and influence how governments, competitors, and consumers approach the automotive future. It's not just about who can make the best EV anymore, it's about who can offer the best solution for every situation. The same powertrain is used in the hydrogen-powered Corolla Sport, showcasing Toyota's commitment to exploring sustainable alternatives to traditional gasoline engines. BMW has also entered the race to develop hydrogen-powered vehicles with the production of the BMW Hydrogen 7 beginning in 2006. The Hydrogen 7 featured an internal combustion engine that could run on either gasoline or liquid hydrogen, making it a versatile option for drivers looking for sustainable alternatives. Other companies like JCB have also explored alternatives to diesel engines that are more sustainable and eco-friendly. In collaboration with Nissan in 2019, JCB installed a fuel cell in a prototype 20-ton X-Series excavator. Despite the promising results, battery cells remained a challenge for the company. After much research and experimentation, JCB made the bold decision to focus on hydrogen-powered engines. They believe that hydrogen holds the key to a cleaner and more sustainable future, and they were determined to develop engines that could match the power output of diesel engines while emitting zero greenhouse gases. Their engineers set to work developing fuel cells that could convert hydrogen into electricity to power heavy machinery. JCB's team of engineers worked tirelessly for a grueling 2 years, burning the midnight oil to develop over 50 different prototypes of their hydrogen-powered internal combustion engine. It was arduous, but their commitment to creating a sustainable future for heavy machinery never wavered. Finally, after countless hours of testing and refining, they arrived at a patent they were satisfied with. JCB's newly developed hydrogen engine was a game changer, a zero-emission alternative to electric cars and fuel cells that could, really revolutionize the heavy machinery industry. As a manufacturer of heavy-duty machinery, JCB knew all too well the challenges of electrifying an excavator or a backhoe loader. But with their new hydrogen engine, they had found a solution that could bridge the gap between utilizing existing combustion technology and keeping things simple, cost-effective, and, most importantly, emissions-free. Aside from JCB, companies like Porsche and BMW were working on similar projects. Returning to Toyota, the company has been testing fuel cell semis in California's bustling Los Angeles and Long Beach areas. These modified Kenworth tractors have been hauling goods, and the results have been nothing short of impressive. Thanks to their success, Toyota has now received the coveted approval of the California Air Resources Board to start selling a fuel cell kit. What does this mean for the future of transportation? Well, it means that anyone can now build their own hydrogen-powered rig, ushering in a whole new era of eco-friendly hauling. Chris Rovick, the Executive Program Manager of Advanced Mobility at Toyota Motor North America, is a visionary in the world of sustainable transportation. He firmly believes that hydrogen engines will play a critical role in reducing emissions in the heavy-duty transport industry, and he is not alone in thinking this. Companies like JCB and Toyota are at the forefront of this movement, pioneering the development of cutting-edge hydrogen engine technologies. Rovik is confident that these engines can deliver the power, distance, and fueling times that fleet and individual operators need to keep their operations running smoothly. As we've seen, hydrogen engines are quickly gaining traction in the world of transportation, and they have the potential to revolutionize the way we think about eco-friendly transport. While electric vehicles have been grabbing headlines in recent years, the rise of hydrogen engines is proof that there's more than one way to build a sustainable future. Indeed, the road ahead for hydrogen engines is not without challenges. One of the biggest hurdles is the availability of pure hydrogen fuel. While the infrastructure for hydrogen fueling is growing, it's still in its infancy. But experts are optimistic that with continued investment and innovation, we can build a network of hydrogen refueling stations that rival traditional gas stations. What do you think about this? Let us know in the comments section down below.